That's right. Burning the time away. You can access that at home.
No.
Yeah. It's on YouTube. It's on YouTube.
We should see if we can put our hands on the real
No. All right, ladies and gentlemen, good morning. So today, sorry, we are going to start our discussion on section 3, and we're splitting it up into 3 separate portions. Today's discussion isn't going to be terribly long, but we do have to do some examples and walking through it, okay? And before we get there, beside your notes, I want you to locate any copy of your periodic tables that you've been given throughout this year. Have those handy. If you 100% absolutely cannot find a copy, I have one up here. Huh? That's a lot. Plus, there's one in that packet that I gave at the beginning of the year.
Oh yeah, that's been ones on.
That's a bummer. Those are always nice to have. Does anybody not have a periodic table? Come on up.
Didn't you watch my movie? Okay, well, I gave mine away to him.
So, you will definitely need the periodic table for what we're going to be doing in this section. Now, what everyone doesn't have that is going to be of use for you, especially early on, is what Judah's going to pass out to you. You mind giving everybody one copy of that? What Judah is passing around is a form of the periodic table. However, you'll notice that it doesn't have the elements or any other information regarding elements on there. What it has are numbers and letters. Okay? So, those numbers and letters are what we are going to be working with pretty much for the next almost week. Okay? And those of you at home, I'll get the PDF copy to you here after class.
I've never been on a single one of your. I've been on one.
Back when we were doing like remote stuff, I didn't do Google Meets, I did videos.
Yeah, because I've never been on this one.
Thanks, sir. All right. So, just taking a quick look at what Judah just gave you. As you see, we got, for instance, at the very top left corner, we have the letters 1, S, and then the superscript of 1. Let's talk about and break down what these mean. The big one, so the very first one there, that is your principal quantum number, your N. The S is the orbital which it is in. And that superscript of 1 is the number of valence electrons, I should say, valence electrons in that orbital. It probably looks just like gibberish to you right now, and it should, really. Okay? But we are going to utilize those numbers, and we are going to essentially develop the electron configuration of elements. Not every single one, but select few. The reason for that is, as we progress through the periodic table, we have to deal with electrons. They have to go somewhere. And based off of everything we've been discussing up to the latest quantum mechanical model, these electrons have to go into regions of space. And these regions of space are dealing with energies. So we are placing these electrons that we are going through into certain energies in certain regions of space. Again, and these electrons are not stuck there, but these are probable locations because we can only mathematically determine where they should be. All right, so let's get into our brief discussion today and talk about ground state electron configuration. So what electron configuration is the arrangement of electrons in the atom, simply put, okay, according to the quantum mechanical method. And really we can do this because atoms always want stability. They always want to be stable in regards to their electrons. And so for atoms to be stable, they assume the electron configuration that gives the lowest possible energy. And so that's what this is doing. It's arranging them in the lowest possible energy, which is its ground state electron configuration. So I'm not going to even deal with this periodic table. It's not my favorite. Okay, I like this one. What we're going to do with this one is just label regions of this period. Okay, now I printed off this document that you just got from Judah with about 10 minutes, close to 15 minutes left in the last period, which is when Mr. Hampton teaches it. And caught him a little late. He was about 30% through listing and labeling every single element and the numbers that you have on yours by the time I got to him. So you don't have to do that. Okay? All you have to do is the following. Okay? So, and you can figure out how you want to do this. Okay? If you want to use a key, if you want to use different colors available to you, or whatever, it's no big deal. It's up to you. We are going to label the 4 different colored regions of this periodic table utilizing those 4 letters of orbitals. What's one of the letters of the orbitals that we talked about yesterday? S. Very good. What's another one? P. I heard someone. You said D. D. Heard someone else say another one. F. S, P, D, and F. So this blue is the S orbital. And also, while I have you on the slide, this slide probably looks really weird when we say this is the periodic table. This is actually how the periodic table should look. Except when it comes to printing it on canvas or whatever like this, the lanthanide and actinide series make it a little difficult. Start getting cramped for space. So they just kind of cut it, removed it off to the side. Kind of like in maps when you have Alaska and Hawaii just kind of placed right there. And honestly, people have actually thought that Alaska and Hawaii were right next to each other because that's how maps portrayed them. They're a little far away. All right, so these two columns, which matches up with these two columns and helium. So you might even say like, well, this box isn't here on the periodic table. That's because it is helium. So you just want to put helium right there. That's what that is. And to get technical, if you will, or you'll hear me describe it, I might as well write it down how I describe it. Call them blocks. Those first two vertical columns are the S block, including helium, which on the periodic table is found all the way over to the right. This tan section is the F block, or the F orbital. Again, that's these down here. Okay, the lanthanide and actinide series. Now, I want to bring something up that I also had you write down yesterday. I want you to tell me how many electrons max can the F orbital hold? 14. Count with me here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many can the S orbital hold maximum? 2. 1, 2. There's a method to my madness most of the time. Let's shift on over to this orangey block. Okay? This is the D block. These elements in the D block are right here in the middle. These are the transition metals. How many max electrons can the d orbital hold? 10, yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those numbers are coming into play. And lastly, what do you think this pinkish block is? The P block. And so that's everything in this here. Okay. And the P orbital holds how many max electrons? 6. 1, 2, 3, 4, 5, 6. Okay. Hopefully you wrote those down as well, because it's going to be very helpful for you later on. All right. Now let's look at how we create an electron configuration. So the steps to writing electron configurations, the first thing is, well, you have to locate the element in question on the periodic table. And number 2, I kind of go about it a different way. If you want to, you can do it this way. Correlate that location to the location on the electron configuration periodic table, which is, kind of what I gave you as a reference. After a while, you probably won't need that table that I just gave you. Then you will write the electron configuration for each subshell. So that means your S, P, D, and F in order. one thing you need to remember, and when you see the examples, you'll kind of get a better grasp on it, but only the highest electron configuration needs to be written. So again, for the s orbital, we said that it could only have, or could hold a max of 2 electrons. So when you're writing the electron configuration, you only have to write the biggest one. So as an example, 4s2, you do not have to write 4s1, 4s2. Okay? How, and I'm going to continue on with this notes here in a second, but how I usually relate electron configuration creation or development is going on a trip. Okay? You go on a trip, you document everywhere you've been through, everywhere you stopped, and that's what your electron configuration is. Every time you enter and exit a new block, you document it. Now, as you go through and do enough electron configurations, you'll find that there are exceptions to the typical rules. The D block and D subshell oftentimes lose electrons. They don't necessarily follow the rules. And I'll be honest, I try to steer you clear of any elements that don't follow the rules. So with that being said, in some of the practice ones, I have actually changed at least one of them. Okay? So you want to make that note when we get there. So like chromium, it does not follow the rules. It has 4s1, 3d5. For copper, it's got 4s1, 3d10. Again, none of these are following the standard operating procedures. Okay? But what the reason for it is, it does allow for those particular atoms to have increased stability. So on that table that I gave you, you're going to notice that there's looks like there appears to be some repeat numbers with some of the elements, and that's because those are the ones that don't follow the rules. And again, those are the ones that I try to steer you clear. Now, when we do electron configurations, what we call the longhand version, we always start at hydrogen. And so for early elements on the periodic table, it's not so bad doing that version. However, when you start getting into like right around here, when you're dealing with elements in the 80s and 90s and things like that, you can get a very lengthy electron configuration, and it becomes kind of overbearing. There is a second way to do this, and we call it the noble gas or shorthand notation, where you locate the, let's say, telluriums right here, okay? Element number 52. That would be a lot of writing if you did the longhand version. So what we could do is the noble gas configuration. You locate the element in question on the periodic table, and then locate the previous noble gas. So you do this as you go up the road, all the way over. And what that does is, you've all taken algebra, right? Or at least are in algebra, right? In algebra, oftentimes you use a variable to substitute in and stand for something, correct? That's all this is doing. The noble gas that you determine is going to be used is substituted in, and it stands for all of the previous stuff. So you significantly shorten your electron configuration that you have to write. So today we are going to do both of those versions. Okay? Now, before we begin, have any of you ever heard of a typewriter? All right, a few of you. Make me nervous that some of you haven't. How does a typewriter work? You typey, 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 typey. You get to the end of the row, or end of the line, and then you do what, Tristan? You push it back. It goes ding, and you push it back, and what happens? You start the beginning, but the next row. You're going to hear me reference that as well. Just like a typewriter. You get to the end, ding, you start back up at the beginning all the way to the left. In conjunction with going for a trip. Okay? It's just easier to talk that way. Okay? So before we begin, number 2, as you'll see, I have changed. Okay? I believe you have silver, AG. AG doesn't play by the rules. So I changed it. Okay? To IN. Now, excuse me. We are going to begin our first electron configuration. First step is we have to locate our element in question on the periodic table. First one is phosphorus. It is right here. What block is it in? What was that? P block. Very good. All right. Keep that in mind. That's where our destination is. We are going to start our road trip. And we are doing the longhand version, so we are starting at hydrogen. Okay. Now, how do we do this? What row is hydrogen in? Row 1. And what block are we starting in? S block. Very good. Let's start our journey. 1s. What's it say in your paper for that table for hydrogen right there, upper left-hand corner? 1s. 1. I'm going on my journey now. Starting. I come to helium. I'm at 1s2. Again, I only have to write the maximum number of each block that I cross. So 1s2. I don't have to write every single one. Otherwise, you'd be very angry with me. Okay. Like a typewriter. I've come to the end of the road here. What do I have to do? I go ding, and I go back to the beginning, down a row. Now what row am I in? 2. What block am I starting in? 2. So if I got to my destination at phosphorus, I haven't, have I? So I continue my journey. I'm at 2s1, 2s2, hop across the pond, and now what block am I entering? P. I'm in the P block now. So, as I mentioned a few moments ago, anytime I exit a block, I have to document it. So, I exited 2s at 2. So again, that 2s2 is beryllium. Hopping across the pond here, I get to boron. I'm still in the second row, right? So I'm still in 2. But what block am I in again? Say it louder. P. Okay. Let's continue our journey because we haven't got to our destination yet. 2P1, 2P2, 2P3, 2P4, 2P5, 2P6. Am I where I need to be yet? No. But again, I've reached the end of the road. Ding. But I'm also leaving the P block. How many did I count to get to the end? Not 8. In the P block, how many did I count? 6. So I've got to document that. 2P6. And another row. Ding. Typewriter motion. Back to the beginning. Another row. What row am I in now? 3. What block am I in? S. Am I to my destination yet? No. 3s1. 3s2. Hop across the pond, but what happened here? I left the block, so I have to document it. Now I'm in the p block. 3s1, 3s2, 3s3. Am I at my destination? But then I stop. How many did I just count? 3. And that is the electron configuration for phosphorus. You can also think of it as kind of like a map to get to a specific element. Because I could also flip the way we do that. I could give you this and ask you what element has this electron configuration. And you just simply go through the periodic table. Okay? Now, our next one, I'm going to throw you a curveball in terms of what we have to do. Because what has been yet to be mentioned in the notes is what happens when we cross into the D block or the F block. The D and F are weird areas, okay, in terms of their quantum numbers. Okay? Now, I'm going to go back a couple slides, and I want you to add this to your notes. We're going to come back and do indium on this slide. Okay, again, we said this is the D block, and this is the F block. Right? All right. Now, when it comes to numbering, and when I say numbering, I'm talking about the row numbers. So, as an example, 1s2, 2s2. So when it comes to those big numbers, the D block and F block change slightly. So, again, these big numbers are our principal quantum numbers. What letter do we represent principal quantum numbers with? N. Very good. A lowercase n. Principal quantum number. Okay. When it comes to crossing into the D blocks, F blocks, these numbers change. For instance, if we have that as our unknown element, okay? So we go 4s2, and then we enter it's the first time entering the D block. It is not going to have a principal quantum number of 4. It actually has a principal quantum number of 3. So there's a rule of thumb here. For the D block, n minus 1. Okay, for the D block. I'm going to quiz you here. Go to the next row. We have 5s2. What do you think the number is going to be? 4. Very good. I think it even lists that on your table. So if you get stuck, you can always reference that. The F block is, again, slightly different. Okay, the F block is n minus 2. So here, in the 6th row is the first time we enter that area. We have 6s2, 4f. Okay, so F is n minus 2, D is n minus 1. Okay? Now, let's get back to this so I can give you your practice. Indium. Right here. Okay? So, we're going to practice doing a long one. All right? So, longhand version, we always start at hydrogen. And we begin at 1s1, 1s2. I'm going to take a step back. I'm going to ask for your input. Okay? So 1s2. We hit the end of a road. Ding. Typewriter it over. Where do I go next? I go to 2. We're at P yet because we got to start back over. All the way over here. And what block is that? S. Okay? Have I got to my destination yet? So I continue my journey. And so I've got to leave the S block, and I put what up here? Somebody tell me? 2. Very good. Hop across the pond here. I'm in what block now? I'm in 2P. And I keep on counting. 1, 2, 3, 4, 5, 6. Still not at my destination. I document every time I come to an end of a block. I keep following this pattern. It is very pattern oriented doing this. So again, hop on over. I am now at the 3S, and I continue my journey. 3S1, 3S2. Still not at my destination, hop across the pond. Now I'm over in what block again? Don't be shy. B. And I keep on going. 1, 2, 3, 4, 5, 6. Still not at my destination. It's a long journey. But I've reached the end of this road. Typewriter it, ding, move on over. On to the next one. 4S. What number is going to go up here? 2. Very good. But now, I'm entering a new block. Entering the D block. So, what principal quantum number am I going to write here? Well, it's going to be n minus 1 because I'm in the 4th row right now, but D value is going to be n minus 1, so it's 3. And then I'm continuing on my merry way, counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got to the end of the D block. Oh, I forgot to put D here. And I put 10 there. Still have not reached my final destination. As you can tell, this is why it's very important for us to have the shorthand version. So what block am I in now? I'm back in P, but also look what happens. I'm back in the 4th row. P6. I'm gonna go to the end of that road. Super long trip. So I'm here at Krypton, ding. I think I'm getting close to being done on this one. I now am in the 5th row. 5S2 gets me out of the S block and back into the D block, which is going to have a principal quantum number of 4. And I heard someone say 10. And that gets me out of the D block, back into 5P. Very good. And that's finishing the journey. Now, before we kind of wrap things up here, I give you your work. I just want to do a shorthand version example for you so you have an idea of what we're talking about. Okay? All right, so let's look at indium and do the noble gas conversion. Sorry, not gas conversion. Noble gas electron configuration. So here's indium. In order to do this correctly, we have to identify what is the previous noble gas. Again, noble gases are all the way over here. So here's indium. They may tell me what the previous noble gas will be. Krypton, very good. And so what we do, we put krypton's symbol in brackets. And so krypton is right here. It is actually going to substitute in for this entire chunk of work there. Krypton, because really this is right here, all the way up to 4p6. That is krypton's electron configuration. So we substitute it in. Using the element symbol, we just continue on where that left off. So 5s2, Kr 5s2, 4d10, 5p1. Shorthand version right there. Much shorter, much simpler. So this is what you're going to practice this weekend. Okay? As you leave the room, make sure to grab one of these. I will be posting the solutions before Tuesday. Make sure you check and look at it, and then we will discuss it before we continue on. Make sure to grab one. Yeah. Have a good weekend. That's a control back to a student. Are you just reading here, or is that you just put them there? You got one already? Yeah. You already did. Are you sure? I didn't think so. Okay.